Hello students, in the last videos we discussed the mathematical calculus, that is the derivative and integration, and we solved some of the numericals what required in our due course of time. While we discuss more and more, we need this differentiation and integration. We discussed that thing. Next we will go for the new chapter, that is your mechanics. We will discuss about this mechanics. So the question comes in your mind that the mechanics here in this chapter, the mechanics is also a very vast topic. Here we are concise to discuss only about the motion in a straight line. That part we will discuss. And the mechanics, we can say that it is the oldest topic in our physics. So first is what is this mechanics? So the mechanics is, we can say, the branch of physics which deals with the motion. It is the branch of physics which deals with the motion and rest of a body under the action of forces. So the motion and rest of a body we will discuss in this mechanics. It is the branch, the oldest branch, we can say that the oldest branch of physics. Here we will discuss the motion and rest of a body. The motion and rest of a body under the action of forces. As you know, if you apply a force, then the body is under motion. Then you can ask a question that why if you are applying a force at the body is at rest, means this rest is means we can say it is the equilibrium. You are applying a number of forces, but the body has no motion. It is at rest. So that part we will discuss here. So that is the rest, or you can say motion and equilibrium. In place of rest, you can write this as an equilibrium. So that is the mechanics. And as I already told that the mechanics is a very vast topic. So this mechanics consists of three branches. The mechanics consists of three branches. So now it divides into three branches. It has three branches. They are statics, kinematics, and dynamics. These are the three branches of your mechanics. So in mechanics, we first discuss about statics. So what is the statics? Statics, we can say that the branch of mechanics which deals with the study of the bodies, or you can say the objects, the study of the body or the objects in equilibrium, means the body or objects in equilibrium. So you can say in equilibrium, or you can say rest under the action of forces. There are action of forces. We are applying number of forces, but the body is in equilibrium, or you can say the body is at a rest. Okay, the body is at a rest. That is the statics. So static means, as the name it says, statics means the body is at a rest under the action of number of forces. Then the next one is the kinematics. So here in this kinematics we will deal with the study of the motion of the body. The motion of the body under the action of forces without going in detail about the account for the cause of its motion. Let me repeat again. Kinematics is the branch of mechanics which deals with the motion of a body or motion of bodies without taking into account of the cause of its motion. Means we will not discuss why this motion happens or by what factors the motion is there. We will not discuss all these things. In kinematics, we will deal only with the motion, or that motion is called as the mechanical motion. We can say that mechanical because this is the mechanics branch of mechanics. So we can say the mechanical motion of a body, motion of a body without the cause of motion, without the study of the cause of motion. We will not go for the cause of motion in this part. Next we will go for the dynamics. Here what we will discuss in this dynamics the study of the mechanical motion of the body by taking into the account of the cause of motion. Why this motion happens? Why the motion is there in the body, but by what factors the motion comes, that we will discuss in dynamics. So here you can say the motion of the body with the study of cause of motion, without the study of cause of motion. So let me make it clear that when we discuss this kinematics, there we will not go for the cause of motion, as it is a simple thing that comes in our mind that the motion because of a force or energy, all these factors are there, that is the cause of a motion, and that part we will not discuss in kinematics. In dynamics we will discuss about this cause of motion, but here we will discuss about the motion of the body. Means if the motion comes in a body, then what are the factors associated with the body when the body is in motion. So we can say when a body is in motion, it covers some distance with respect to time, it has some velocity, has an acceleration. That part we will discuss in kinematics. Then statics is the body in equilibrium, that part we will not go for. We will discuss that in our topic is your kinematics. We will discuss about the kinematics. Okay, so let me start the kinematics, that is our chapter in mechanics. That is in our mechanics, that in kinematics we will discuss about the motion of a body. So we will go for the kinematics. So first we will discuss kinematics, that is in our topic, in our syllabus. Then we will go for the dynamics in next chapters. Okay. Then, so kinematics, again I am repeating, the kinematics is the branch of mechanics which deals with the study of mechanical motion of the bodies without taking into the account of the cause of motion. Clear? Then, now when we discuss about this kinematics, first comes in our mind that what is the rest and motion. First we will discuss what is this rest and motion. What is this rest and motion? Now I will ask you, what do you mean by rest? So you can say that rest means the body does not change its position with respect to time. So you can say that is at rest. What is motion? The body changes its position with respect to time or with respect to its surrounding. So the body changes its position with respect to its surrounding. Surrounding means what? What we are finding around us, that is my surrounding, our surrounding. Okay. So if the body does not change its position with respect to its surrounding, then the body is at rest. If it changes its position with respect to the surrounding, then it is called as a motion. Now take a simple example that suppose you are sitting in a train with your friend. You are sitting in the train with your friend. Now in that case, when you are with your friend inside the train and the train is moving, moving on the track in a straight line. Okay. When you find that, if you find a object or a tree through the window of the train, you say that the train is in motion by observing that. Now when you see your friend, when you find your friend near you, you can say that your friend is at rest. But if I am standing outside the train and the train passes nearby me, and if I observe that, I can say that both of you are in motion. Both of you are in motion. But for you, your friend is at rest. So the same thing, for the same event, you are in the train along with your friend. The same thing for two persons, the same thing is different and the explanation is different. That gives me or gives us a concept of absolute and relative. Relative to you, your friend is at rest, but relative to me, for me, your friend is in motion. Your friend is in motion when both of you are in the train. So in this concept, the rest and motion, it depends on the observer. The observer. You are an observer to know the state of your friend. I am an observer to point out the state of your friend. Isn't it? Okay. So that means my point is here, the rest and motion depends on the observer, or we can say we are standing at a point, at a place where I imagine that I have a scale with me and a time measuring device or a clock with me. With respect to this clock, with respect to my position with a length or a scale, your position is changing. So I can say your friend or your friend's position is changing or your position is changing, because both of you are in that way, you are changing. So that is relative. That is relative. And I am at a point and I think that the observer itself is called as a frame of reference. The observer itself called as a frame of reference. So that comes here. From here we will go for the frame of reference. So here what we got, that the rest and motion what we are discussing, these are relative. These are relative terms. These are relative terms. And the question is, nothing is absolute. Nothing is absolute. Means neither the rest nor the motion is absolute. Means you cannot say, because let me make more elaborate this thing. When I will ask you, what is the position or what is the state of this body, this chalk? You will say that it is at rest. But if you go from above the surface of Earth and you observe from another planet, through a device, you find that the chalk is not at rest, it is in motion. Why? Because we are on the earth is in motion. So how can this body at rest? Because we are on this body. So it is the earth and the body is here. The earth is rotating, so this is also rotating. But as both of us are on this earth and we all are in motion, so we feel that we are the tree or a hill or a building is at rest. But for a person outside this earth, this is not at rest. So nothing is absolute. So what we measure here, all are relative to a frame of reference. Relative to a frame of reference. Now I will go for the concept of frame of reference. So next is the frame of reference. So what is this frame of reference? Now try to understand this frame of reference. So the fixed point or a place with respect to which the position, or you can say the velocity or the acceleration, that is called as the kinematic parameters. If you know the position, the change in position, the change in distance, the change in velocity, all these things gives the different terms. So I am not going about these terms, we will discuss later. So the frame of reference, we can say that a fixed point or place, a fixed point or place, a fixed point or place, that is the fixed point or a place to which the kinematics parameters means the physical quantities, velocity, speed, acceleration, position, distance, displacement, these are the kinematics parameters. The kinematics parameters of a body is known as what? Frame of reference, is known as frame of reference. Clear? So that is the fixed point or a place. So I am fixed and I am observing everything. So when the fan is at rest, this building is at rest. So for me, I am a fixed, I am a frame of reference. If I go to another planet and if I observe from that planet to Earth, I will find that yes, this is not at rest, this is in motion. So there I am again another frame of reference. So the fixed point or place to which the kinematics parameters of a body is measured is known as frame of reference. And the frame of reference are like the Cartesian coordinate system. The frame of reference are Cartesian frame of reference, right, or Cartesian coordinate system. This can be the frame of reference, may be Cartesian coordinate system. Clear? Then the other may be the polar coordinate system, and the frame of reference may be cylindrical coordinate system, So this polar, or this is also the spherical polar coordinate system. We can say this is the spherical polar coordinate system. Both are the same thing. Okay. So there are different types of frame of reference. It may be Cartesian coordinate system, polar coordinate system, or spherical polar coordinate system, or cylindrical coordinate system. Okay. But we will discuss here about the Cartesian coordinate system. It is already well known to you. The Cartesian coordinate system. We will not discuss for the polar or the spherical polar coordinate system and the cylindrical coordinate system. We will not discuss because that is not used in our further discussion. We are generally used with this Cartesian coordinate system. What is this Cartesian coordinate system? So in this Cartesian coordinate system, how to locate the position of a object? What is this Cartesian coordinate system? Okay. So this is a frame of reference. In this Cartesian coordinate system, let us consider these are the different axes in space, x, y, z, and you are the observer fixed at the origin. In Cartesian coordinate system, in space, in 3 dimension, there are three axes, x axis, y axis, z axis. So this is my x axis, this is y axis, and the space is your z axis. I am here. If I go in this direction, x axis. If I go up, y axis. If I go here, that is I am moving along z axis. So there are 3 axes, and the observer, the fixed point where you are here, think that you are here at the origin of the coordinate system. So if we look at the position of the point P, then generally we give that in a coordinate system x, y, z. So what it means? It means if I start from here with a meter scale, if I go x distance along x axis, then y distance along y axis, then z distance along z axis, then I will reach at this point P. So for it is not possible to show the 3 dimension. I have shown this is for 1 dimension. In 2 dimension, x and y. So if you go up z axis, z distance, then you will reach at the point. Means the point is not here, the point is here. So to reach that point from here, I go x distance, then y distance, then comes z distance. Then I reach at the point. That is the position. And then already you know that this is the reference point where you are the observer there, and this is the xyz. So already you know that. To know that, we can representing a position vector as r. So this r is equal to, already you know that, xi cap yj cap plus zk cap. So this gives you the direction parts, and these are the distance travel along x axis, y axis and z axis. So this is the called as the Cartesian coordinate system, where we are measuring the frame. We are the frame of reference. In a frame of reference, then comes here in this Cartesian coordinate system, the frame of reference, the Cartesian coordinate system is of 2 types. One is, means in this frame of reference, in Cartesian coordinate system, the frame of reference we can say that of 2 types. One is called inertial frame of reference. One is called inertial frame of reference. One is called inertial frame of reference. The other one is called as the non-inertial frame of reference. Non-inertial frame of reference. One is inertial frame of reference. The other one is the non-inertial frame of reference. So what is this inertial frame of reference? Now try to understand this inertia. So any frame of reference which is either at rest, means I am a frame of reference, I am at the origin of a xyz coordinate system. Think like that. Then I tell you, when I ask you about a frame of reference, you say that yes, I am a frame of reference and I am observing a event, the position or the distance or the any parameter of a object, and I am a frame of reference, means I am at the origin of a xyz coordinate system. Okay. So what is this inertial frame of reference? A frame of reference which is either at rest or moving with uniform velocity. The frame of here at rest or moving with uniform velocity. You will understand this uniform velocity. What is uniform velocity? If I cover along this direction 5 meter in each 10-minute interval. First 10 minute I am starting from here. In first 10 minute I cover 5 meter. Then next 10 minute I cover next 5 meter. Again next 10 minute I cover again 5 meter. So I can say along the same direction, if I am moving, then I can say that is a uniform velocity. We will discuss in detail about this uniform velocity when we discuss about velocity in this chapter. So here a frame of reference which is at rest or moving with uniform velocity is called the inertial frame of reference. Is called as the inertial frame of example. Is a inertial frame of reference. Yes. So in this inertial frame of reference, remember one thing, we will discuss about this Newton's law of motion. That already you know that Newton's laws of motion. So these Newton's laws of motion is applicable in the inertial frame of reference, and then in inertial frame of reference, you can say that if truly speaking, we are not at rest. So if we are not at rest and if we are in motion, in non-uniform motion, generally our motion is non-uniform. We cannot maintain this uniformity. So if we are not in uniform motion or we are not at absolute rest, because with an observer outside we are on the surface of earth and the earth is revolving, so we are also moving with the earth. So my observations is not like your inertial frame of reference, but practically you can consider that yes, what the measurements we are doing is the inertial frame of reference. If we consider that the earth is moving with uniform speed around the sun, around its own axis, but that is not uniform, we can say. But if you consider like that, the small little bit of changes we can neglect, then we can say that yes, I am also moving in the same uniform velocity and I am observing something, so that is the inertial frame of reference. So in this, a train moving on a horizontal track, the train moving on a horizontal track. So in that case, the train when moving on a horizontal track with a constant velocity is an inertial frame of reference, is an inertial frame of reference. In the uniform track in a straight line, the direction is not changing and the train speed is also constant. Then we can say that if you are on the train and the train is an inertial frame of reference. From that train, if you observe something, then you can say I am measuring everything from my inertial frame of reference. Next, the non-inertial frame of reference, or that is also called as the accelerated frame of reference. What is this accelerated frame of reference? Means the frame of reference or the observer is not at rest, and moving with non-uniform velocity, then that is a non-inertial frame of reference. So what we can say that, so a frame of reference which is moving with non-uniform velocity, that is called as the accelerated. A body is moving with non-uniform velocity, then it gives you acceleration. The body is accelerating. You are on your scooter, on your motorcycle, you are moving on your motorcycle. When you accelerate, that means at some place you are moving with a speed, at a place, the crowded place, you make your speed or velocity decreases, then you take a turn, then you move here, there, then that motion is called as your accelerated motion. That is the accelerated motion. Clear? But on this national highway, if you are moving and there is no more disturbance, anything, and you are moving with a constant velocity on a straight line, then you can say that yes, your acceleration is zero. You are in a uniform velocity. But when you are moving in this town, then you will go here and there, your motion will be here and there, and you make slow or make speed or you increase the speed. So in that, the moving with a non-uniform velocity, and that motion is called as the accelerated motion. And from there, if you observe something, then you can say you are a non-inertial frame of reference. And remember that the non-inertial frame of reference, the Newton's laws of motion is not applicable, and the forces acting in here or the forces coming in non-inertial frame of reference are called as the pseudo forces or fictitious forces. The forces are called as the pseudo or fictitious. Fictitious means it has no significance. Fictitious. So these are the pseudo or fictitious, Fictitious, fictitious forces. And Newton's laws of motion is not applicable in non-inertial frame of reference. Then now we'll go for is the earth is a inertial or non-inertial frame of reference. Already I have given the explanation for that. Here, yes, the earth is not at a uniform velocity. So, but if we do consider the large scale motion of the earth, large scale motion such as, or the, if we will not consider, it means if we will not consider the large scale motion on the surface of earth, but we will consider the motion of earth. So large scale motion of the earth means the wind speed, the ocean, the motion of the motion such as the wind and ocean currents is not considered. We can make the approximation that the earth is an inertial frame of reference. The earth is inertial frame of reference, that is for consideration. Is that clear? So these are the inertial and non-inertial frame of reference. Now students, we will go for the types of motion. So next we will go for the types of motion. What are the types of motion? So broadly you can say that there are three types of motion. I can say broadly there are three types of motion. One is a translational motion. We will discuss one by one. Translational motion. What is this translational motion? So translational motion, we can say a body has translational motion if a line joining any 2 points on the body remains parallel to itself throughout the motion of the body. Clear? Write down this thing. A body is said to be in translational motion if a line joining any 2 points of the body remains parallel to itself throughout the motion of the body, then the motion is called as the translational motion. So now let me take an example like this. Suppose there is a body like this. This is a body, and there are 2 points. Consider there are so many. A body is consist of a number of points, right? The number of points means number of molecules. You can say that each molecule you can consider as a point, or each atom you can consider as a point. So let me consider there are 2 points on the body, right? So these are the line joining the 2 points of the body, A and B. Now if the motion is said to be translational motion, when we can say that a translational motion? So the body in translational, if a line joining any 2 points on the body remains parallel, yes, remains parallel to itself throughout its motion. Now let the body goes to this position. The same body goes to this position. So now the body along this path, it goes to this position. Clear? The body goes here, this position. Now what about this A and B? They are remain here, A and B, this line. Now these are parallel. Now let the body comes to here. At this position, now the body comes here. The same body comes here. This is A and B. Are they parallel? Yes, they are parallel. This line, this line, this line, this line, this line, and this line, all are parallel. So any 2 points throughout its motion, it remains parallel to itself throughout its motion. That is called as a translational motion. Then what are the examples of this translational motion? The examples are, you can say, a train moving on a straight line. The train is moving on a straight line. A body falling freely or vertically downward. The body is falling like this. So this is a what? Translational motion. Means if the body is here, let us consider these 2 points. Now comes here. These are the 2 points. They are parallel to the initial position. Then it comes to here. Then it goes to the ground. Then the 2 points are parallel to the previous one. So that is the what? The first type of motion, that is the translational motion. And during the translational motion of the body, there is change in the location of the body. It is here, now here, now here. The location changes, and this motion is also known as the rectilinear motion. This motion is also known as the rectilinear motion. The translational motion is also known as the rectilinear, on a straight line motion, rectilinear path. Light travels in rectilinear, or the rectilinear propagation of light means light travels in a straight line. Clear? So like that is the rectilinear motion. Then comes to your number 2 is the rotational motion. What is this rotational motion? Rotational motion. This rotational motion comes here. A body has rotational motion if it moves, you can write this thing, if it moves around a fixed line, if it moves around a fixed line, okay, and that line is called as the axis of rotation, the line is called as the axis of rotation, such that all the points or the particles constituting that body, means the body is made up of these particles or the points constituting the body, move simultaneously along a concentric circles having their centers at the axis of rotation. Clear? Let me repeat again. A body has are said to be in rotational motion if it moves around a fixed line called axis of rotation, such that all the particles constituting the body move simultaneously along a concentric circles having their centers at the axis of rotation. Let me take like this. So let this is the body. It is moving along this line xy. Now the body comes from here. Now it goes to this position. The same body goes to this position. So this is the fixed line, right? Now the body goes here. Let us consider the points like here on this body. The different points are 1, 2, like this. Now when the body comes here, like this. So when the body comes from here to here, then comes like this, about this axis it is rotating, then the lines joining this. So this particle when it comes from here, so it goes along this path like this, like that. Then it will goes to this point like this. Then it goes along this point to like this. So this is the point or line, and the body is moving along this path. The particle is moving like this. Similarly, this particle is also moving. This particle, let me show. So it covers simultaneously covers a circular path. It covers this point covers a circular path. The whole body is rotating. Each point covers a concentric circles like this. So now this particle also like this, it covers a concentric circular path like this. So above this fixed line, all the concentric circular path, this point is rotating. Think that this is a point rotating about this one, and the center is here. For this one, the center is here. For this one, the center is here. All the centers are fixed, right? So this is called as the rotational motion, and this line is the axis of rotation, and this is the center of rotation. Center of rotation. For example, is that suppose the axis is here, right? Okay, or you can take the window of your room. The axis is where the window is fixed at one end, so that is the axis of rotation. Now when you rotate this window like this, then if you are not able to open the window 360 degree, but how much you are rotating, so that is called the rotational motion. If you rotate that completely, means if you see where you are holding, where you are holding, if you move that window like this, that point where you are holding, think that that is a point, that point covers a circular path if you are able to rotate that 360 degree. So above this axis, the window is rotating like this. Okay. So this is the rotational motion, and here the examples you can say that the rotation of earth around the sun. So the rotation of earth around the sun means we are on the surface of earth, the earth is rotating around the sun. So you think that I am a particle, you are also at your home, you are also a particle. So you are covering a concentric circle, and I am also covering a concentric circle if the earth complete one rotation around the sun. So that is the rotational motion. So, and here we can say that during this rotational motion of a body, there is change in the orientation of the body, while there is no change in the distance of the body from the axis of rotation. The orientation of the body changes means if I am the axis of rotation and suppose this is rotating around me, so this is an object rotating around me, so the body can orientation can changes, but the distance from this point, suppose consider this is the point, the distance from me, this point does not changes, the orientation can changes, but this does not changes. Okay. So during the rotational motion of a body, there is a change in the orientation of the body, while there is no change in the distance of the body from the axis of rotation. Okay. So that is the rotational motion. Clear? Then next we will go for the vibrational motion. Then we will go for the third one is the vibrational motion. Then in rotational motion we will come across with the circular motion. That circular motion comes, we will discuss the circular motion, we will read that in circular motion also. The under this rotational motion you will come across with the circular motion. Then the third one is the vibrational motion. So what is this vibrational motion? The motion of a body is said to be vibrational. The motion of the body is said to be vibrational if it moves to and fro after regular intervals of time about a fixed point called the mean position. Clear? Is that clear? Means the body, suppose this is the body or a object, and this is called as the mean position, where it is at rest, consider that is the mean position. But the body is vibrating about this mean position to and fro like this, to and fro. This is to and fro motion about this mean position. This is called as the mean position. About this mean position, the body is vibrating, not like this. It is not moving from this point, but at the same point, like this is the mean position, and the body is moving here and there, up to and fro, in regular intervals of time. It is moving to and fro. This motion is called as the vibrational motion. The molecules in the object, in this object, the molecules, they are in vibrational motion. They are vibrating inside the body. So that is the vibrational motion. Okay. So the motion of the pendulum in a clock, that is also a vibrational motion. Okay. Then the motion of the simple pendulum, that is also a vibrational motion. Means the pendulum is here, that we can say that is the mean position. About this mean position, it goes to one extreme, then it comes to the mean position, then goes to another extreme, then comes to. So that is called as a vibrational motion. The pendulum is vibrating, or you can say that is also oscillating. Okay. So these are the different types of motion. But when we consider these types of motion, here we are considering, so this is a body, right? So when I am considering that a train is moving in translational motion, I gave an example that the train is in motion. So when you consider the train in motion, what the portion at that engine side, that is not there at the guard side. Means at the end. What is there is the position of the particle at the position at the front side is not, or it is a far away from this particle which is at the front to the last one. So means a object, when you are considering an object, means the object, when you consider this object also, this is not a object, maybe when we are considering the motion of this body, maybe a translational, vibrational, rotational. So in that case it gives you a little bit of difficulty that each point on this body has different orientation or different position. So the shape and size, that means the dimension of the body is of different from considered to this one and this one, the dimension is different. For different dimension means if we consider the motion of the train in a straight line, and if you consider the motion of this chalk in a straight line. So if you consider the dimension of a train compared to this one, that is a very big object and this is a very small object. So in that case, this gives you a little bit of difficulty. So to overcome that, we will consider generally, we will consider the idea of a point object. We will consider the idea of a point object. In kinematics, we consider the idea of a point object. So what is a point object? An object is said to be a point object or a point particle if its dimensions are negligible as compared to the distance traveled by it. The dimension of this object is negligible as compared to the distance traveled by it. This chalk is a point object if it covers 3 km. But, or if this chalk, let me take an example like this. If this chalk, the dimension means shape size, that is the dimension. The dimension of this chalk is negligible as compared to a distance traveled by it. Suppose it covers 100 meter, then the dimension of this chalk is very negligible. The dimension of this chalk is very negligible compared to its distance traveled. But if a train moving 100 meter, then the dimension of the train cannot be neglected compared to the distance traveled. In this case, this can be considered as a point object, but the train cannot be as a point object. Similarly, if the train travels 100 km and the size of the train is called as a point object. On that basis, we consider the concept, or we understand the concept of a point object. Okay, so a point object is just as a mathematical point. A point object, suppose this is a body like this and this is in a motion like that, then we can consider, we will not show like that, I will consider yes, this is the point and it covers the distance like this. So that is the mathematical, or you can say this is the mathematical point. This concept is introduced to study the motion of a body in a simple manner. This is introduced to understand the motion, translational, rotational, vibrational, circular, right? In these motions, to understand it in a simpler way. So we can say that the point object or a particle, the point object or a particle is a model of a real object that helps us to locate its position at a single point in the space, or on a coordinate system or in a frame of reference. Suppose I will consider this XY frame of reference like that. Suppose I say you a train is here, means we will not show this train complete like and show that yes, this is the train at this position and you are the observer here. So you can locate like this. This is the, to make the things simpler. If you draw a train like that, what is the length of this train, then you will consider this point or this point or this point or this point, that gives you difficulties. So to make the things simpler, we introduce this point object concept. Okay, now we will go for the motion in 1 dimension, 2 dimension and 3 dimension. So now come to what is this motion in 1, 2 and 3 dimensions. Okay, so motion is in 1 dimension. When the motion is said to be in 1 dimension, 1D I can write motion in 1 dimension. When we can say that. So the particle means a point object or a point particle. A particle is moving along a straight line or a path is said to be 1 dimensional motion. Means let us consider a particle is moving like this. So this is the position A. Then the particle comes to the point B, then the particle comes to the point C. So here at this point, suppose this is in the coordinate system like this. So let's consider this coordinate system in Cartesian coordinate system. The particle moves from A, B, C like that. So in this motion, it is in 1 dimensional motion. Means let us consider at this point A, what is the coordinates of the point? Suppose let us consider the ZX is not possible here. Let us consider this and you are the frame of reference. Cartesian coordinate system. Now here to locate this position A, what the coordinates, let the position is x1 and this is your obviously y1. That is the location of a point. How we locate x1 and this is a y1. Now when the particle goes to B, how much the exchanges? Now the exchange is to x2. But what about y1? Y1 remains same, so it is y1. Then when the particle goes to C, now exchanges to x3, x2, so this is x1, x2, x3. And what is this position? This is y1. So everywhere y1 fixed. only one coordinate changes. So that motion is called as one-dimensional motion. Clear? So in one-dimensional motion, to describe this motion, what we need? Position of the particle in one dimension. To describe that, only one coordinate changes. During the motion, only one coordinate changes. Then that is called as a one-dimensional motion. So the motion on a straight line, an object, suppose this is the chalk moving on in a straight line. So when it moves in a straight line, only one coordinate changes. So the motion in the straight line is a one-dimensional motion. Okay. Then now go for the two-dimensional motion. So in this two-dimensional motion, when this two-dimensional motion comes, the motion in two dimension, then in two-dimensional motion comes if the body moves in a plane. This is the board, this is the plane. On this plane, the body moves from A to B. So suppose the body moves from A to B along this path like that. So to locate this position A, what are the coordinates required here? x1, y1. When it goes to B, what are the coordinates? Naturally x changes to x2, x1 changes to x2. Here it is x1, here it is x2. Then obviously this is y1, now y1 changes to y2. So x1, y1 changes to x2, y2. So in this plane, the body is moving on this plane and there are two coordinate changes. Clear? So a particle moving in a plane is said to be two-dimensional motion, and since two coordinates are required to describe the position of the object in a plane, since there are two coordinates changes during the motion, two coordinate changes during the motion. If you take this as z-axis is also there, but the z-axis is not changing, means the bodies are moving on this plane. So that is a two-dimensional motion. So the motion on the plane means if you move, so this is the duster, this duster is moving like this on this plane. When I am erasing this thing, this is a what type of motion? On this plane it is moving, here it is a coordinate, I am standing here, I am here, this is an object, I am here. So this is a one coordinate. Now it goes here, two coordinate changes. But if it goes like this, then it comes here, then it comes here, then there are two coordinates are not changing, three coordinates are also changing. So that is not a two-dimensional motion. So means the motion in a plane. Okay. So when you are playing with the carom board, the striker moving on this board, when you are the striker moves on the board. So that striker motion is a two-dimensional motion. Then the next one is the three-dimensional motion. In three-dimensional motion, the body moves in the space. The motion of a body in space, is called as the three-dimensional motion. So in three-dimensional motion, the three coordinates of the body changes. Three coordinates changes, and it is not possible to show you how the three coordinates changes in Cartesian coordinate. We are discussing only in a Cartesian coordinate. Means if this is the body like this, in the frame of reference like that, and this is the position, suppose A. Now the body from A moves to B. So let that consider this is the point B. So in this part, the three coordinate changes we can show x1, y1, z1 changes to x2, y2, z2. So when the body moves from here to there, in space, the motion in the space, and it is not possible to show the space motion on this board. So you think that the motion in the space is a three-dimensional motion, and the examples you can say that the motion or when the kites are in the space, that is a three-dimensional. A bird is flying, that is a three-dimensional motion. A bird is flying in the space, that is a three-dimensional motion. Okay, so these are the different types of motion we discuss in our topic, that is the kinematics. Okay, so dear students, go through these whole videos. These are the fundamental things we should know in kinematics. Okay, so next we will go for the different kinematic parameters, what we will use the kinematic parameters to describe the motion of the body without going through the cause of the motion, that we will discuss in the next video. Okay students, thank you.